Okay, so now that we understand a little bit more about work, energy, and their equations, let's do some practice problems. So we'll start with practice problem number 1, which was example 8. You have a half-kilogram ball being thrown vertically upward with an initial velocity of 10 meters per second. Now we want to know what's the ball's change in kinetic energy between the starting point and its maximum height, and the change in potential energy between those two same points, the starting point and the maximum height. So start out with understanding or thinking back to how objects move through space, right? When you throw something, it'll form this parabola shape, which I've drawn over here. And so what you can see is that you want to understand the nature of this maximum height point. So what is happening? When you throw it up, it's increasing in speed. So the velocity is changing in the y direction as you go up, right? Because it's going up. And then after this maximum point, it starts to go down, right? And so what you see is that basically at that maximum point, in between going up and going down, it had to stop, right? And so what you can say is that the velocity in the y direction at that point in time was 0, right? And then acceleration took over and it started to go back down and increase in velocity. And so this gives us this right here, that v of y is equal to 0 meters per second at the top. And then you can just plug into the equation of delta k, right, to find out the initial answer for the question. So you plug in delta k's k final minus k initial. We said that the final was equal to 0 because the velocity is equal to 0 at that point. So this just becomes 0. So then you continue and you get negative 1/2 mv naught squared, and when you plug it in, you get this value right here of negative 25 joules, right? And now we need to understand, what does the potential energy look like then, if that's the case? And so what you get is delta k is equal to negative delta potential energy. And so you get positive 25 joules. And so what this is telling us is that its kinetic energy went down from the starting point to the maximum height. So it kept decreasing in kinetic energy, right? But the potential energy increased. And so why does this make sense? So let's break that down, right? As you go up, right? What's happening is there's motion happening here, right? But remember, for any object, potential energy is the highest at the maximum point, right? And it's lowest at this point right here. And so since we're at max height, potential energy has to be the highest there. Kinetic energy is the lowest. And so what you get is when you're going up, kinetic energy is changing, but it's basically losing kinetic energy. It's in the negative direction, right? But potential energy is increasing as you go up. And so what happens is you end up with these values right here, where one, kinetic energy is negative and potential energy is positive, because they have to equal 0 for conservation of energy. Now let's move on to another one. This one has to do more with potential energy. A 60-kilogram skier is at the top of a slope, right? And I've drawn that out for you right here. And at the initial point A, she is 10 meters above she's 10 meters vertically above the point. And so when you set the 0 level for gravitational potential energy at B, find the gravitational potential energy at A and then at B, and finally the change in potential energy from point A to B. So let's stop here for a second, right? What it's saying is this is initial point A, that's where the skier is, right? If you say that this distance, let's make this a little bit easier for you. this is what the initial problem is saying. This distance is 10 meters between each other. And so all we have to do is go back to our potential energy equation, right? And we can just easily plug in for MGH, and you get your potential energy at point A. And then if we say that the potential energy at point B, it's on the ground, it's just going to be 0, right? There's no distance being moved at all. And so what is the change in potential energy between point A and point B? It's negative 5,880 joules. And then you go back, and now it tells you the new 0 point is now at 8 meters, right? And so there's this point right here. And so what you can say is that, okay, now that that point is 0, now my point A is at 0 joules, and my point B is 5,880 joules. And so the change is 5,880, right? And so why is that? Because it said, repeat with 0 level at point A. So now point A is our 0 point, right? So if point A is our 0 point, then we have to plug in 0 for distance over here. So it's basically these A and B are just opposites of each other, right? And so now we have one more thing to figure out, is the 0 level is 2 meters higher than B. And so if we go back to the original, it was 10 meters, now it's at 8 meters, right? And so that changes our numbers slightly. We put 8 instead of 10, and then we get our numbers. And again, now because we're not at our 0 point, we're actually at -2, because our 0 point is over here. Sorry, our 0 point is right here at this point. And because our 0 is 8 meters away from here, we still have point B, which is under the 0 by 2 meters. And so that's where this -2 comes from. And then again, there's this change right here of -588 joules.